Hello Nova Online Math 161. In this video, we're looking at section 3.2, topic 2, graphing exponential functions. Use the graph of y equals 2 to the x power to graph the function. Write the domain and range in interval notation and write the equation of any asymptote. So, well, we have four things to do here, right? We're going to find the domain, range, and they did say write the equation of any asymptote, but for exponential functions, we have horizontal asymptotes. So we will find the equation for its horizontal asymptote. And lastly, we will graph f of x. Okay? All right, let's start by talking about the domain of a function. Okay? Well, they did want us to use the graph of the simpler y equals 2 to the x power, right? So I'm going to talk about this function that we actually have to graph in relation to this simpler basic y equals 2x function, okay? So that's the one we want to graph, okay? This is the one we want to graph. But let's start by talking about this basic, simpler y equals 2x function, 2 to the x power function. Now, domain of any exponential function is always going to be from negative infinity to positive infinity, okay? All real numbers. Why? Well, let's think about it. What are some possible x values that we can plug in here? So in other words, like what numbers are allowed to be an exponent? For square root functions, we were not allowed to plug in anything negative. For fraction function, rational functions, we were not allowed to have 0 in the denominator. But there's no restriction for what kind of numbers can be in the exponent, okay? So you can have 2 to the 0 power if you want, and that is just going to be 1. You can have 2 to the negative third power, and that's just going to be 1 over 2 to the third power, which is 1 over 8. So you can really plug in anything you like into the domain, into the x value for exponential functions. So that's why the domain is going to be all real numbers. Now think about this for me. Look at the first transformation getting done to this x. By shifting this graph 3 units to the left, that's the effect of adding that 3 right there. We are shifting the domain 3 units to the left. Let's talk about that. So this adding 3 have an effect of shifting the graph 3 units to the left. And that rule is coming straight from chapter 1, section 6, when we talked about the transformation of function. Now, let's think about this. The domain used to be negative infinity to positive infinity. What happens if you shift that 3 units to the left? Can you do negative infinity minus 3 and positive infinity minus 3? Will it make any difference? No, not really, right? It's still going to be all real numbers. So no matter what kind of exponential functions you have with any kind of horizontal translation, it's always going to be from negative infinity to positive infinity for its domain, okay? Easy to memorize, right? Domain of any exponential function is always from negative infinity to positive infinity. Now, we do need to talk about the range though, okay? I'll tell you that the range of this basic function that doesn't have any vertical translation is just from 0 to infinity, okay? We will not be able to have a y value that is smaller than 0 or equal to 0. But look at the function that we need to graph. What will this adding 2 do to the graph, okay? Thinking about that transformation rules. This adding 2 will shift the graph up 2 units. So the range will change, okay? You have to go up 2 from 0, and you have to go up 2 from infinity, okay? So what happened to the first value? If you do 0 plus 2, the range will go from 2 to, but look at the second part. I know that's a little silly. What's infinity plus 2? Well, that's still infinity. So it doesn't change. The whole vertical shift doesn't change the upper limit here. It's gonna go up forever. But it did change the the lower limit for this range here, right? Now let's talk about the very last one, the horizontal asymptote. So I'm gonna go back to this basic function, y equals 2 to the x, and tell you that the horizontal asymptote for that function is y equals 0, okay? Now, but if you shifted this graph 2 units up, f of x will have its horizontal asymptote also shifted up 2 units. So the horizontal asymptote will not be at y equals 0 anymore, but the new horizontal asymptote for this function will be at y equals positive 2. So notice how these two are very closely related. The range and the horizontal asymptote of an exponential function depends on the vertical shift of the function, okay? But domain is going to be always all real, okay? So we found 3 things already. We know that the domain is negative to positive infinity, range is 2 to infinity, and the horizontal asymptote is y equals 2. Now the only thing that we have left to do is graphing this function. So let's graph down here. Let us graph f of x equals 2 to the x plus third power plus 2. Now let's start by sketching the xy axis. Here's the x-axis. Here's a y-axis. And what I'm going to do is I'm going to go up 2 and plot or sketch the horizontal asymptote at y equals 2. So this is going to be like our little guiding line. The graph will not cross. All right, I think I should move it down just a little bit. There we go. All right, so there's no trick to graphing this. We just have to maybe plot some points to figure out where our dots are so that we can connect them. So let me start by plugging in some numbers, okay? So what are some good x values that we can plug in? And just like we talked about, the domain of an exponential function can be anything. So really, there's no wrong answer. There's no wrong choice for an x value. But here's what I'm thinking. Watch. I think it will be really nice if I plug in negative 3 here. Because wouldn't negative 3 plus 3 give us 0 for the exponent? So I think I'm going to start by just plugging in negative 3 for the x value. If x is negative 3, then the y will be 2 to the negative 3 plus 3 plus 2. Now what's that going to be? This will be 2 to the 0 power plus 2. Anything to the 0 power is just 1. So we're looking at 1 plus 2, which is 3. So we found out when we plug in negative 3, we get 3 out. So we will be plotting our first dot at negative 3, 3. So I'm going to go 3 to the left, 1, 2, 3, go up 3, 1, 2, 3, and plot the first point right here. I'm going to plot just one more point, okay? I'll just plot one more point. What if I plug in, this time, negative 2? And again, you can pick any x values you like, but I'm just thinking that if I plug in negative 2 here, notice negative 2 plus 3 will just be 1. So that will be an easy small number for me to evaluate. So if I plug in negative 2, I will get 2 to the negative second plus 3 plus 2. And that turns into 2 to the first power plus 2. And 2 plus 2 is just 4. So we found out that when x value of negative 2 went in, the y value of positive 4 came out. So we will be plotting the point negative 2, 4. So go 2 to the left, up 4, 1, 2, 3, 4. There we go. And now I'm just going to graph this function using the asymptote. To the left of the function, you will keep on going down, but when you get closer to this horizontal asymptote, you will never be able to touch it you will never be able, this graph will never be able to cross this horizontal asymptote. So just try to draw a long tail that is kind of bounded by this horizontal asymptote. But to the right side is going to go up, because remember the range is from 2 to infinity. So it's going to go up forever. So we're going to graph a the right end to be just going up to positive infinity. And if you do want to plot one more point, I think the next good point will be the the y-intercept. If you want to plug in an x value of 0, let's say that if you plug in 0 into this function, let's see what we get. Well, that is 2 to the third power plus 2, and 2 to the third power is 8, and that's 10. So notice that, wow, the exponential functions increase very quickly. So when you plug in 0, the y value is up at 10. So I don't think I was going to be able to plot 0, 10 because my graph is going up not that fast. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like somewhere up there it was going to touch the y-axis. But when you are graphing your exponential function on your exam, I mean, of course, the more points you have, the more accurate your graph will be. But if you can graph it using the horizontal asymptote and the right or the left end behavior looking at the range, then you should be able to have a good sketch with just plotting maybe 1 or 2 plots.